Time travel is a concept that has interested humanity for centuries, if not millennia, and has been mentioned in many forms of literature, from ancient Hindi texts to the fantastic works of great artists like Mark Twain and H.G. Wells. While these may be works of fantasy, there is a very real phenomenon known as time dilation that is built into the physics that governs our universe as we know it, and may one day allow humanity to bend time to its will. While this version of time travel is a far cry from Doc Brown's DeLorean or the amazing blue police box in Doctor Who, it is just as impressive in its effect on the world around us as its science fiction counterparts. Time dilation is a property that is built into Einstein's theory of relativity. This theory takes the view that time and space are two sides of the same coin, and when one is manipulated, the other is also affected. The closer to the speed of light a particle travels, the slower time passes for that particle relative to the rest of space-time. This theory can be tested using muons, a particularly massive particle similar to an electron. They are often found in Earth's upper atmosphere, and due to their short lifespan, should not be detected at Earth's surface. However, muons have been detected in underground laboratories. This has led some scientists to theorize that time dilation, caused by the near light speeds at which the muons travel, is allowing the particle to extend its lifespan, and thus allowing their detection in areas where they theoretically should not reach.
With the aid of a proton synchrotron, we aim to generate and accelerate pion particles. As pion particles decay to murons, we will then force murons down a parallel beam and allow them to travel in a straight line through a vacuum tube. By calculating the mean difference travelled by murons and their average decay time, we will be able to determine if the experimentally obtained decay time is greater than average decay time at rest, suggesting that time dilation has occurred. Through this research, we aim to expand our knowledge into designing experimental plans, further research of time dilation and time travel to eventually aim for possible time dilation effects on larger particles. As our proposal begins with lab-based research, our risk assessment has identified that radiation, strictly within the radioisotopes of manganese-54 and cobalt-60, can be present during particle acceleration, as bombardment can chemically change iron and cobalt. Furthering this, a particle accelerator has the theoretical potential to generate a black hole. Finally, as our understanding and development of time travel and time dilation increases, all information should be kept as public as possible to acknowledge developments and increase overall understanding.